Hi everyone, we are pleased to present our case study titled Risk Assessment Using Hirarc Analysis Case Study of an Industrial Incident. This presentation is brought to you by myself, Muhammad Farhan bin Muhammad Faisal, along with my teammates Ahmad Rishdi bin Ruzali and Muhammad Zafran Iskandar bin Razi. Together, we explore how the Hirarc methodology can be applied to real-world industrial disasters to improve safety and prevent future tragedies. Let's begin with a brief introduction. Risk assessment is cornerstone of occupational safety and health management. It involves identifying hazards in the workplace, evaluating the risks they pose, and implementing effective control measures to mitigate those risks. One of the most widely adopted frameworks for this process is hierarchic hazard identification, risk assessment, and risk control. To demonstrate the importance and application of this method, we chosen to analyze the Piper Alpha oil platform disaster, one of the deadliest offshore industrial incidents in history. This case offers valuable lessons in risk management and highlight the consequence of systematic failure. Now we go to incident background. The Piper Alpha platform was located in the North Sea of the coast of the United Kingdom and operated by Occidental Petroleum. On July 6, 1988, a catastrophic gas leak occurred during maintenance work on condensate pump. Due to poor communication between shifts and a breakdown in the permit-to-work system, the pump was restarted without proper safety isolation. This led a massive explosion followed by multiple fires that engulfed the platform. Tragically, 167 workers lost their lives and the entire structure was destroyed. This incident underscored the critical need for robust risk assessment and control mechanisms in high-risk industries. In the following section, we will apply the hierarchy frameworks to this incident, identifying key hazards, assessing the risks involved, and proposing control measures that could have prevented such a disaster.
Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Rushdi bin Razali, and now I will present my part, which is incident description. Right, so first the background. The Piper Alpha platform located in the North Sea, approximately 190 km northeast of Aberdeen, Scotland, was operated by Occidental Petroleum. It was initially commissioned in 1976 as one oil production platform and later converted to handle both oil and gas. At the time of the incidents, Piper Alpha was one of the largest offshore oil and gas platforms in the United Kingdom, producing around 300,000 barrels of oil per day. The incidents on the night of July 6, 1988, routine maintenance was being carried out on condensate pump A. The pump's pressure safety valve had been removed for servicing, but the pump was mistakenly marked as available for operations. During the evening shift, condensate pump B, the backup pump, failed, prompting operator to attempt restart. Hey, since it was not fully sealed, this led to a significant gas leak. Within minutes, the leaking gas ignited, which causing a massive explosion that damaged nearby equipment and pipelines. Multiple secondary explosions followed, escalating into an uncontrollable fire. Next, the causes and consequences. The causes: first, poor communication between maintenance and operation team led to pump A being restarted unsafely. Second, failure of sensor system. The platform's automatic control system was switched to manual mode and failed to activate. And third, design vulnerabilities. The platform's layout allowed the fire to spread rapidly with oil and gas pipeline feeding the flames. For the consequences, fatalities, 167 workers killed and only 61 survived. Platform destruction, Piper Alpha was completely destroyed, with damage estimated at over $3 billion. It became the world's deadliest offshore oil disaster, leading to significant reform in offshore safety regulation, particularly the Golden Report 1990, which introduced stricter safety management systems in the oil and gas industry. That's all from me.
Hazard identification and risk assessment. Hazard description. First, gas leaks during maintenance, incomplete isolation and faulty equipment, likely 4. Catastrophic 5. Risk level extreme. Presence of flammable material second. High pressure oil and gas store or process. Almost certain 5. Catastrophic 5. Risk level extreme. Third, poor communication and PTW failures. Inadequate shift and over. Miscommunication possible 3. Major 4. Risk level high. Fourth, failure of fire suppression systems. Equipment malfunction, poor maintenance. Unlikely 2. Catastrophic high. The last, human error in operation, inadequate training, procedural lapses, possible 3. Major 4. Risk level high. Risk control, hierarchy of controls. Hazard, gas leaks, elimination of substitution, replace manual isolation with automatic shut-off, engineering controls, install gas detectors and pressure relief valves, administrative controls, strict permit to work enforcement, PPE, flame resistant, closing gas mask. Second, flammable materials, minimize storage of volatile materials, automatic fire suppression and emergency shutdown, safer process design and audits, fire retardant suits, emergency escape gear. Third, poor communication and PTW failures, engineering controls, digital PTW system with alarms, administrative controls, clear handover protocols, training supervision. And the fourth, fire suppression failure, redundant and regularly test firefighting systems, schedule maintenance and inspections, fire resistance PPE for emergency response. And the last, human error, replace outdated procedures with safer designs, engineering control, safety interlocks on equipment, comprehensive training and safety culture, standard PPE for offshore workers. And the conclusion, the pipe the Piper Alpha disaster demonstrates how failure in hazard control, communication, and emergency response can escalate risk into catastrophic consequences. Through higher analysis, it becomes evident that gas leaks, flammable materials, poor communication, and human error were critical. Hazard contributing to the incident. Applying effective risk control measures such as automated safety systems, strict permit to work, procedures, regular equipment maintenance, and proper training could have reduced the likelihood and severity of the accident. This case study highlights the importance of systematic risk assessment in preventing industrial accidents and ensuring worker safety in hazardous industries like oil and gas. This is the picture of the incident. Thank you. That's all from us.